Hi, my name is Scott Simpson, and today I'll be talking about unit conversions. Unit conversions are a very valuable tool in chemistry and in physics and engineering because it allows you to go from one form of SI units or units that are common in whatever subject you're looking at to a different set of units, which is very valuable. In some cases, there's a lot of real-world applications of this, even when you're considering changing from pounds to kilograms and things along those lines. So before we get into that, we should probably talk about how to do unit conversions. Well, they're fairly simple. Normally what you do is you look for your starting unit. Then you usually multiply that by some fraction, and this is the conversion factor to go from your starting unit to your end unit. And this will give you your end unit that you desire. And sometimes this can go in a very simple way where you have your starting unit, your end unit. If you notice, what ends up happening is you'll cancel these out and you'll end up with your end unit. That's how you know you've done the calculation properly. I know lots of students don't like to do it this way, but it's one of the simplest and easiest ways to go about doing this. Now let's take an example. So even though this is a simple problem, let's look at if we have $150 people, how many feet do we have? And that's assuming nobody's a pirate. So there's no one-legged person hobbling around. So an easy way we can do this. We start off with our 150 people. We just have to have our unit conversion. So how can we get from people to feet? Well, we know for every one person, there's one people, each person has 2 feet. Knowing this, we just have to multiply across. And if you notice, people cancels out, so we end up with a unit of feet. So 150 times 2 should get 300 feet. Now let's expand this question to something that has more than one step in it. So, for my example, if a boat holds 300 people, how many feet? Are on 6 boats. So let's assume each boat holds 300 people. So let's first mark off what we know and what unit we're starting with and where we want to get to. How I do this is I box off the information that we know with a dotted box, and then I underline the information that we want to know. So we want to know how many feet. And we know that we have 6 boats and there are 300 people per boat. So, we have 6 boats. For every one boat, we have 300 people. And for every one person, we have 2 feet. So first thing to check, we need to check to see if our units are correct. can do that easily by canceling out our units, which ends up happening. And then all we have to do is multiply through. So we should have 6 times 300 times 2 feet. Take that a bit further. Basic math, go. So 12 times 300, 3,600 feet. So let's move to a more chemical type example. All right, and how do I know these unit conversions? Well, I just figured them out. You either have to do a bunch of problems and learn it, but you can use logic to get to that point. So, chemistry related problem. How many atoms of oxygen are there in 4 grams of oxygen? So, remember, dot off what we know. So we have 4 grams of O2, diatomic O2 gas, and we want to know how many atoms of oxygen. So we're going to be starting with grams, and we have to get to atoms. So a good problem, or a good way to start these problems in chemistry, when in doubt, always convert to moles. It'll usually help you out. So, we have 4 grams of oxygen, or of O2 gas. We need to multiply that by a conversion factor. So I said, let's convert to moles. Moles are one of the central units in chemistry that you can get to. And it's basically the molecular weight per mole. So, in the case of O2 gas, there are 32 grams of O2 gas for every 1 mole of O2. So, how do we get from moles to something useful? Well, let's think about it. A mole is like a chemist's baker dozen. A mole contains 6.022 times 10 to the 23rd items. This can be atoms or molecules, it can be cars, elephants, whatever you want to do. So we know that we have 1 mole of these O2 atoms, right? So if we have that many moles of O2 atoms, for every 1 mole of O2 atoms, we have 6.022 times 10 to the 23rd molecules of O2. We can take this a step further. For every 1 molecule of O2, we have 2 atoms of oxygen. So will this end up working out to what we want it to? We can figure this out through our units. If our units cancel, we're most likely going to get the correct answer. Grams are gone, moles of O2 are gone, molecules of O2 are gone, we're left over with atoms of oxygen. So our final unit should be atoms of oxygen. If we look, that's what we're looking for. So we should be pretty good. After we multiply this all through, what you should end up getting is 1.51 times 10 to the 23rd atoms of oxygen. So that's how you can go through and convert units. Now, some tips. Like I said, when in doubt, just convert to moles, because in chemistry, that's most likely going to help you. Try to think of them as puzzles when you're doing these. All it is a puzzle. You're trying to start from a starting result and getting to an end result. And then the other thing to keep in mind is you need to determine the info you know and the information that you want to know. So keep that in mind. Either do it visually or mentally. Either mark it off right in the question or just do it in your head. So I hopefully have shown you enough on unit conversions that you get the idea. I can be reached at my email or on my YouTube or Facebook page. Thank you very much. Have an awesome day.